Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Hanisha binti Hairuddin and my matrix number is 2021449082. In this video, I'm going to talk about carbon compound and how to name the isomers. There are two types of carbon compound, which is organic compound and inorganic compound. But in this video, I'm only going to talk about organic compound, which is hydrocarbons that contain alkene and alkene, alcohols, and carboxylic acids. Let's take a look on hydrocarbon. So, hydrocarbon contain carbon and hydrogen atoms only. There is no other atoms other than carbon and hydrogen. Next, hydrocarbon has two types, which is saturated hydrocarbons and unsaturated hydrocarbons. So, how we differentiate between these two types of hydrocarbons? For saturated hydrocarbons, it must contain single bond between the carbon and carbon, while the unsaturated hydrocarbon, it must contain at least one double bond of carbon-carbon or triple bond of carbon-carbon. Just remember, saturated is for single bond, while unsaturated is for double bond or triple bond. For saturated hydrocarbons, or known as alkene, has general formula, which is CnH2n plus 2, where n is equal to 1, 2, 3, and so on. Then, saturated hydrocarbon does not really have functional group, but we call it as alkyl group. Alkyl group is representing the bond between the carbon, which is single bond. I'm going to teach you on how to name the isomers of alkene. First of all, find the longest continuous chain of carbon atoms in the molecule and name the longest chain as the parent chain. So 1, 2, 3, 4 carbon. So as we know, 4 carbon is butane. Next, we name the branch chain that attached to the parent chain as alkyl group. So it is 1 carbon, and we know that 1 carbon is met. Because it is alkyl group, so we add the til at the back to represent the alkyl group. The third step is identifying the position of the alkyl group based on the lowest carbon. If I count the carbon from the front, it will become 1, 2. And if I count the carbon from the back, it will become 1, 2, and 3. So, I choose 2 because it is the lowest number of carbon. Then we identify the next branch chain that attached to the parent chain. It also has 1 carbon. So don't forget to add di in front of the methyl because it has the same branch, CH3 branch. Then the position is also 2 because it is based on the lowest carbon. Finally, jot down the name as 2, 2 and add the hyphens to separate the numbers and words. Dimethyl butane. For unsaturated hydrocarbons, or known as alkenes, has a general formula which is CnH2n, where n is equal to 2, 3, 4, and so on. 1 is not included. And alkene does really have functional group, which is carbon-carbon double bond. This is how you name the isomers of alkene. First, look at the longest chain of carbon. As we know that for carbon is butane. It is butane because it is from alkene. Next, we look the functional group of alkene, which is double bond. So it is on the position of carbon number 1, not carbon number 3, because we must choose the lowest number of carbon. So we put the 1 in the middle of butane. Don't forget to add hyphens to separate the words and the numbers. Next, we look at the branch chain that attached to the parent chain, which is 1 carbon, and it has single bond, so it represents the alkyl group. Next, we must identify the position of the branch chain that attached to the parent chain. So it is on the 2nd carbon, not on the 3rd carbon, because we must choose the lowest number of carbon. Finally, jot down the answer as 2 hyphens to separate the words and numbers, methyl but hyphens 1 hyphens in. So that's the name for these isomers, which is 2-methylbut-1-ene. Next is alcohol. The general formula for alcohol is CnH2n plus 1 OH, where n is equal to 1, 2, 3, and so on. As we know, CnH2n plus 1 is the general formula for alkene. So, the CnH2n plus 1 in alcohol represent the alkyl group. Next, the functional group for alcohol is hydroxyl group, which is OH. This is how you name the isomers of alcohol. First, select the longest chain of carbon, and we know that 3 single bond of carbon is propane. The second step is we look at the functional group of alcohol, which is OH. So we need to change the propane to add OL at the back to represent the alcohol functional group. Identify the position of the functional group, which is on the first carbon and not on the third carbon. So we put 1 in the middle. Then the propane will become propane 1-ol. The third step is identify the branch chain that attach to the parent chain, which is 1 carbon single bond, so we know that 1 carbon is met. And we add til at the back to represent the alkyl group. The fourth step is we identify the position of the branch chain, which is on the second carbon, because it is the lowest number of carbon. Finally, jot down the name as 2-methylpropane 1-ol. So this is the last one for organic compound that I'm going to talk about in this video, which is carboxylic acids. The general formula for carboxylic acids is CnH2n plus 1 COOH, where n is equal to 0, 1, 2, 3. As we know that CnH2n plus 1 is the general formula for alkene, but the CnH2n plus 1 in carboxylic acids represent the alkyl group. So, the general formula for carboxylic acids is carboxyl group, which is COOH. Based on the IUPAC system of naming, a carboxylic acid is named by replacing the final letter E of that corresponding with alkane with IOIC acid. For example, if methane, it will become methanoic acid. If propane, it will become propanoic acid. So this is how you name the isomers of carboxylic acids. So 4 carbon is equal to butane. Next, we look at the functional group of the carboxylic acids, which is C double bond OOH. So we need to change the butane become butanoic acids. Next, we look at the branch chain that attach to the parent chain. So there is 2 branch chain that attach to the parent chain. Remember, when naming the branch chain, we must depends on the alphabet. So for example, there is ethyl and methyl. Ethyl, which is 2 carbon, and methyl is 1 carbon. So we must choose the ethyl first because the E comes first, then the M. So identify the position of the ethyl, which is on the second carbon and not on the third carbon. Next, we jot down the second branch chain that attached to the parent chain, which is methyl, because it is 1 carbon and single bond. Then the position of the methyl is on the third carbon because for ethyl we count the position from the back. So for methyl we must count the carbon from the back also. Finally, jot down the 2-ethyl first because it depends on the alphabet between E and M. So the E comes first, and then jot down the rest of the name, which is 3-methylbutanoic acid. The final name is 2-ethyl 3-methylbutanoic acid.